Hey guys, so today's lesson we're moving away from trig functions. We're going to talk a little bit about exponential equations, and then next time hopefully move into a little bit of logarithmic equations to sort of wrap up our year here. So I'm just going to brush through a little bit of recall stuff. If this is stuff you remember and you are solid with it, then by all means fast forward me and get to the examples, okay? Actually, I think I'm going to make two separate videos, one with some basic knowledge and then one that jumps to the examples. So anyway, here we go. So we're going to talk about exponential equations, and let's just review some of the basics of exponents. So whenever you raise something to a power, the piece at the bottom is called the base, okay? And then the upper piece is your exponent. So when I refer to a base, it's whatever we're raising to a power, okay? So, and then here I just want to review a few really common powers that show up all the time. And this, if you're solid with these will help you, or you can even have a list next to you when you do these problems. These will help you fly through this work much faster, okay? So in this first one here, 2 to the 0th power, 2 is the base and 0 is the exponent. If you recall, anything to the 0th power is equal to 1. It's always equal to 1. And the reason being is if you had, let's say, 2 to the 3rd, which is 2 times 2 times 2, divided by 2 to the 3rd, 2 times 2 times 2, well, really, all of those 2's cancel out and leave you with the whole number 1. But this is equivalent to 2 to the 0th power because you would be subtracting those exponents. So that's the reason that anything to the 0th power is always 1. All right. Anything to the 1st power is always itself. So 2 to the 1st is 2. 2 to the 2nd is 4. 2 to the 3rd is 8. 2 to the 4th, 16, 2 to the 5th, 32. You should start to see a pattern just like we did with geometric sequences in the beginning of the year. Every time I go to the next term, I'm just multiplying by 2, right? And that would continue and continue all the way down. So 2 to the 6th, 64, 2 to the 7th, 128, and 2 to the 8th, 256. Okay? Now, you're not going to see huge numbers when we do a lot of these problems, but it is helpful to say, oh, I know 128 is 2 to the 7th power. If you take it all the way back to the beginning of the year, this was one of the expressions that would have been 2 to the n, right? So those are the things with the base of 2. Now let's do with a base of 3. Well, 3 to the 1st is 3. 3 squared, 9. 3 cubed, 27. Again, multiplying by 3 each time. 3 to the 4th is 81. And 3 to the 5th is 243. Okay. I'm not going to go too much higher there just because we don't really see numbers like that as much. But if you want to keep going, just multiply by 3. Now let's try base of 4. Well, 4 to the 1st is 4. 4 squared is 16. 4 cubed is 64. Well, this is going to test my knowledge here. 64 times 4 is going to give me mental math and stuff. 256. And if we did that again, we get 1024. Okay. And then lastly, let's do the sets of 5 with a base of 5. Well, 5 to the 1st is 5. 5 squared is 25. 5 cubed is 125. And 5 to the 4th is 625. And that's probably as high as you need to go, but 5 to the 5th is 3,125. Okay? So these are some common values that are going to come up, and it's going to be really helpful if you can say, oh, 64. I know that that can be written with a base of 4, and I know it can also be written with a base of 2, right? That's going to be really helpful knowledge for you. So that's a little overview there. Rational exponents, this might not come up a ton in this first piece, but just so you remember, anything with a fractional exponent is really the same as a radical. So x to the 1/3 is the same as the cube root of x. X to the 1/5 is the same as the 5th root of x. If I had x to the 3/5, that's the same as the 5th root of x cubed. So the denominator there is the index of your radical, and the value up in the numerator is the power, okay, on your base. So if you have something like the cube root of 2 cubed, well, you guys know that those things cancel each other out, but the reason they do is because this is really 2 cubed to the 1/3 power. And then anytime you have a power raised to another power, you're just multiplying those exponents together. Well, 3 times a third is 1. So 2 to the first power is what we'd get there, which is just 2. That's the same as saying the cube root and the cube cancel each other out, okay? And lastly, we are pretty much already talked about these, but for the exponent rules, when you're multiplying bases, so as long as the bases are the same, you can do this. You're going to add your exponents, or add your powers. So x to the 6th times x to the 7th is x to the 13th power. When you divide your exponentials, you're subtracting your powers. So x to the 10th divided by x to the 6th is really x to the 4th, right? And that's because if we wrote it all the way out, we have 10 x's, and then 6 on the bottom. Well, 6 of those are going to cancel out with the top, leaving just 4 remaining, okay? And then anytime you have a power to a power, you're going to multiply those other powers together. So x to the 3rd to the 4th, you would multiply 3 times 4 and get x to the 12th. And that's because x to the 3rd to the 4th means you have 4 copies of x to the 3rd. Okay? So that's your quick review of all of the exponent rules. And then tune back in and we'll do some examples of